We have an iOS camera application that opens in a full screen mode and turns the iOS live camera feed into 4 kinds of vision understanding. We have Classify for live image classification using a chosen model. We have PVT2 and also Clip. These are all vision models. So once I select Clip, you can see we can classify objects in the live camera feed in real time. We can also detect and predict images with bounding boxes. We have instance and semantic segmentation. The Ask option allows you to ask anything about the scene. This option uses the SpeechAnalyzer API and its speech transcriber model from Apple. So we have 2 different kinds of models for vision, PVT and Clip. We use the Apple Foundation models for the Ask feature. We have MetaSum3 for segmentation. We will use RF-DETR to detect and predict images and use PVT for image classification. So to run this application on your iPhone, you can use iPhone 17 with iOS 27 installed. Since the demo uses CoreAI, we cannot use the simulator to preview this example. You need to enable Apple Intelligence on your device for the Ask feature. As I told you previously, if you select the Ask option, you can add your prompt by writing your text or using voice input. The voice input uses the SpeechAnalyzer API and its speech transcriber model from Apple. With the Ask option, you can use a text prompt or use your voice. What do you see? With low latency, we transcribe the audio using the speech transcriber API. And within a while, we will get a text output from one of the vision models. So let's look at how this was built with all these features: image classification, image detection and prediction, image segmentation, and the Ask AI feature. Before we do that, I also want to show you how the segmentation works. With that selected, over here you have noticed we have a person. So let's remove that. I'm going to change it to Flask and send it. So it is segmenting the Flask using MetaSum3. As you have noticed, the Flask has now been segmented from the other objects in the camera feed. The segmentation is not so accurate like the other features of the app. So let's look at how to build all these features in CoreAI. CoreAI is a new framework from Apple that allows you to bring Hugging Face models to run them directly on the Mac or on the iPad. When you find any PyTorch-based AI model on Hugging Face and you want to use it in CoreAI, you need to convert it to the .ai model format. There are 2 GitHub repositories where you can find such models. The first one is official CoreAI models repository. So this is from Apple. If I click the models directory, you have noticed here they have several models you can use, ranging from language models, diffusion models, vision language models, and more. There is also another GitHub repo, CoreAI Model Zoo. If I scroll down further, here you can also find a couple of models. You can use them in your CoreAI and SwiftUI applications. So since all these models are ready-made, we don't need to convert any model from Hugging Face at the moment. From the application, RF-DETR as well as the MetaSum3 model for object segmentation are downloaded automatically in the app once you launch it for the first time. The PVT model as well as Clip are also added to the project's bundle, so no download is needed for these 2 models. They live right inside the Xcode project. Over here, I have the directory Image Predict Models. We have the Clip model as well as the PVT model. So no download is needed for these 2 models. The image classification is handled in this file. I have added a link to the project on GitHub, so you can download them and try it yourself. Aside the bundled AI models, we have the project files over here. You'll find a link to the project files in the description of the video. So this is a configuration for the live image classification with a user-chosen CoreAI model, PVT, and Clip. We have ImageNet labels. This consists of ImageNet class names and also the CoreAI vision classifier. So you'll find all the project files in the description of the video. For the AI models, you need to grab Clip as well as PVT from the repository I showed in the beginning of the video. You will also find a link in the description. MetaSum2 and also RF-DETR are all found in the repository.